So let's say you're walking along in the woods and you find some interesting object such as this one. Now some of you may recognize this object as the Tesseract from the Avengers, but we don't know much about this object. So as a good scientist, what can we measure? What are some basic measurements we can make to determine some properties of this object? Well, there are three main things we can measure. The first of these being a distance. And in science, we are going to use the unit that most of the world uses, which is going to be the meter, or this abbreviation, m. The distance on this cube, for example, we could measure the distance between one corner and the other. We could, and let's call that length. We could also measure the width, and we could measure the height. Another property of this object that we can measure is its mass. Mass is measured in the base unit of grams, which has the abbreviation G. Mass can be defined as the amount of matter in an object. Now this is very different than weight. If we talk about the weight of an object, that is a measure of the force of gravity acting upon some object. But for the mass will never change no matter what the strength of gravity is where that object is located. It's just a measure of how much stuff is located in that object. So this cube, this Tesseract, has a certain mass that we can measure using a tool such as a balance. Now the third property that we can easily measure with this Tesseract, this object, is the volume. Volume, again, the metric unit for this is going to be liters, which has the abbreviation of L. And I will use the capital L so it doesn't look like an I. So the volume is a measure of the amount of space that the object takes up. Essentially, how big is this object? Now, if I found another one of these Tesseracts, so let's put one in here. This one takes up less space than the one on top. So this has a small volume, and this one has a larger volume. So now that we've looked at the different properties of an object that we can measure in the sciences, let's look at what happens in a more extreme example. So let's see, we're still in the woods walking along, and we come across an ant. And ants are generally not that big, so let me shrink this ant down. And while you're walking in the woods, you happen to be carrying something like a meter stick. So you want to learn about this ant, and all you have to use is a meter stick. Now if I asked you to use the meter stick to measure the ant, it may be a little bit difficult. Ants are much, much smaller than 1 meter. So what can we do to fix that? Well, we need to define a unit that's much smaller. It's much easier to use when dealing with something so small. So what we do with the meter is we start to divide it. So we're going to take this meter stick and we're going to divide it into 100 little pieces, 100 equal pieces. And each of these pieces we will call a centimeter. And the abbreviation for that is cm. There are 100 centimeters in 1 meter. Now, the ability to subdivide our units of measure into smaller pieces or even larger pieces will allow us to accurately measure things such as this ant. Well, now you may be asking, well, how do I know that there are 100 centimeters in a meter? How would I know that there are 1,000 meters in a kilometer? Well, to do that, we have several different prefixes that we use in the metric system. These prefixes are kilo, hecto, deca, deci, centi, and milli. Now notice how I left a space right here between deca and deci. The reason for that is that these prefixes represent larger and smaller units. And these units are the units that we talked about previously. So in this space right here in between deca and deci are the units that we normally think of as grams, meters, or liters. Well, how do we use these prefixes? Well, prefixes go at the beginning of our word to indicate how big our unit is. For example, we can have a kilogram, which is 10 times bigger than a hectogram, which is in turn 10 times bigger than a decagram, which is bigger than a gram, 10 times bigger than a gram, and that is 10 times bigger than a decigram, which is 10 times bigger than a centigram, and is 10 times bigger than a milligram. And you can do this with all of your base units. So you can have kiloliters, you can have a centiliter, a liter, a milliliter. You can do that with mass as well, with meters. Kilometers, decameters, meters, centimeters, and so on. And as I had mentioned, as you go up this chart, up these prefixes, each unit, every time you move up one, becomes 10 times larger. Now, how do we remember this? How do we memorize these units? There's a lot of them. Well, there's a very simple way to do this. And the way I remember it is kings rule over humans, who rule over dragons. Now we have our space for our units, and these are our meters, liters, and grams. And then those dragons rule over dogs, who rule over cats, who rule over mice. So what we have here are the prefixes for all of our units. So we have kilo, hecto, deca, the unit space for grams, meters, and liters, deci, centi, and milli. As you go to the left, every space is 10 times larger. And as we go to the right, each unit is 10 times smaller. Now, how do we use this chart when we are trying to do calculation? For example, let's say I measure my ant in millimeters. So I measure my ant and I get 34.2 millimeters. And it would be more useful for me to know how many meters this is. So what do I do? Well, I'm going to go back to my chart, and I see that I'm starting with millimeters. So I find the letter that corresponds to millimeters. So here is M for millimeters. Now let's see how many places I would have to move to get to meters. Now remember, meters is my unit. So I go millimeters, I move 1, 2, 3 places to the left. I'm going to do the exact same thing with my number. So if I rewrite my number, 34.2, and I move my decimal 3 places to the left. So here's my decimal point, and I'm going to move it 1, 2, 3 places to the left, and this empty space here, that will become a 0. So my answer that goes in here is 0.0342 meters. Now don't forget this unit. You're going to hear me all year saying, don't forget your units, don't forget your units. 0.0342 meters is very, very different from 0.0342 kilometers. You would rather take 400 milligrams of ibuprofen for an aching shoulder rather than 400 kilograms of ibuprofen. So the unit makes a huge difference. Let's try another one. So let's start with 25.4 liters of liquid, and I want to figure out how many centiliters that is. So how many centiliters is 25.4 liters? So again, I go back to my chart. Here's liters, here's centiliters. So liters is my unit. Remember that my unit space is going to be meters, liters, or grams. And I start at liters, which is here, and then I need to move to centiliters. So to go to centi, I move 1, 2 places to the right. So I will take the decimal point on my number and move it 1, 2 places to the right. And when I get my answer, I get 2,540 centiliters. Now, you may come across an example where there is no decimal point already there. So if I give you maybe 5 kilograms to start, and you need to move the decimal point, just always remember that the decimal point is always at the end of your number. So if you do not see a decimal point, it will always be at the end of whatever number you have in front of you.